All right, viewers, we are going to continue in the next topic on that word set. Just like I told you, my name is Sir A Square. So let's fire on. Now, having satisfied the classification of number system in our last video, so today in our next video, we're going to look at classification of sets based on their property, based on their word property. So I want you to watch. Now, I said we'll be considering what we call classification of what set based on their property, based on their what property. Hope you are following. Now there are so many classifications of set based on their what property. The first one we are going to be considering is what we call an element set. So which means set can be classified based on their what element. Now the question is, what is the meaning of an element word set? Now, an element set are those items, those what items contain in a set, in a word set. I repeat, an element set are those items contained in a word set. So the symbol to represent an element set is like this. Look at the symbol. So anytime you see this, we call it an element word set. Or in other words, we call it member of word set. Member of word set. So example now, permit me to use one of the items found in mathematical set. You know that pencil is inside what mathematical set. So which means in abbreviation, we can say that pencil is a member. So can you see this is called is a member or an element of what? Mathematical word set. So that is exactly how to, condense it. Pencil is a member of what? Mathematical set. Okay, let me just say again, like when you are considering what we call natural number, natural what? Number. You know, we said before that the natural numbers are set of positive what? Whole numbers. So it implies that example of a natural number we say is 5. Then I will write 5 is a member or an element of natural number. Can you see it now? So our concern is this particular symbol. It is called an element or member. So, but when you observe in that mathematical set, you agree with me that duster is not inside mathematical word set. So in summary, how do we define duster? We say duster is not a member, it's not what? A member of what? Mathematical word set. So what am I trying to emphasize here? Watch. Anytime you see this symbol E slash, that thing means it is not a member or is not an element of mathematical word set. In other words, if I'm using another number that is not a natural number, let's say -2, I will now say -2 is not a member of what? Natural number. So that is all about an element word set. Okay, now let's move to the second classification. Set can be classified based on their cardinality, based on their what? Cardinality. Now the question is, what is the meaning of cardinality? Now when you are talking about cardinality, what comes to your mind is the number of items contained in a set. What did I say? Number of items contained in a word set is called what? Cardinality. Now I write it. I said number of what? Items contained in a set. Contained in a set is called what? Cardinal set. Now the question is, if I'm using example now, let's say I have something like this, NA. What does it imply? Implies what? The cardinality of set what? A. The cardinality of set what? A. Can you see when there is n before the set, we call it what? Cardinality. That is a symbol to represent a cardinal word set. So in other words, permit me now to go to, to solve one example on cardinality of word set. Now let's start. For instance, if I am given something like this example, if set A is, I have X, I have 1, I have P, I have 2, and I have 3. And the question says find n what? A. To find NA means we are looking for the cardinality of set what? A. Now we don't even need any much protocol to solve this particular what problem. All you should do is to just go inside those items in set what? A, and begin to count the number of what? Items. Yeah, let's go. Yeah, let's start. 1, 2, 3, 4, 5. So directly, I will now just say that the cardinality of set A is equal to what? 5. Have I made myself clear? So how many elements, our members, are existing in set A is just what? 5. And that is the answer. Now, permit me again to go to solve example 2. Now, watch this. If set A is, we have 4, we have X, we have 4, we have 2, we have 2, we have 1, we have P. And the question says, find the cardinality of set what? A. Are you there? Find the cardinality of what? Set A. Now, if the option should be given now based on objective, let's say the first one is 6. The second one, option B, is 7. The third one, option C, is 4. Then the fourth one, option D, is 5. And they said we should find the cardinality of this word item. I know by what I have explained initially, all of you or some of you may decide to say 1, 2, 3, 4, 5, 6, 7, and say that the cardinality is what? 7, which means the answer is what? B. It is wrong. Do you know why I said it is wrong? Is that in a set, repetition is not allowed. It's not what? Allowed. Now, even if a number appears more than 1, that number is being considered as 1. Are you with me now? Like now, if you observe 4 appears how many times? 2. So which means the cardinality is still what? 1. So for 4 now, the cardinality is 1. Are you there? Then we have 2. Are you there? Then for 2 now, the cardinality is also what? 1. So it's not 2. Then if you now count the cardinality now, I will now say 1, 2, 3, 4, and what? 5. So which means the cardinality of the set above is what? 5, which is option what? D. Have I made myself clear? I repeat again. This is 4. This is 1. Are you there? This is 2. I will jump this now because you have already counted it. Then this is 3. Are you there? I will jump this 2 because it's already in existence. So this is 4 and this is what? 5. So the cardinality is what? 5. That is all about what we mean by cardinality of what? Set. Now, let us move to what we call the third word classification. Set can be classified based on their subset, based on their word subset. Now, what is the meaning of the word subset? I want you to watch. A subset is a set contained in another word set. Any set that is found in another set or contained in another set is called what? A subset. I said it is a set. It is a set contained in another word set. In another word set. That is called what? A subset. Now let's take, for instance, example. Let's say I have set X as 1, 2. I want you to watch. 1, 2. Then I have set Y as 1, 2, 3, 4. Now, can you see this now? If you observe this particular set now, set X and set what? Y, you agree with me that everything in set X is contained in set what? Y. But not everything in set Y is contained in set what? X. So, which means this X now, I classify it as what? The son. Then this set Y, I classify it as the father. Can you see that everything in the son is in the word father, but not everything in the father that is in the word son? So as a matter of fact, what do we say? That X is a subset to set what? Y. And how do we write it? X is a subset to set what? Y. So this is called what? Subset. This is called what? Subset. Are you with me now? Now, I still want to you know that This very particular subset can also be represented on a Venn word diagram. How? Now I want you to observe this. If you observe Y, you find out that Y is the father. So which means you represent Y in a bigger word form. Then you move over to set X. X is the son now, right? And the son now will now be in the belly of the father, in the belly of the word father. So what am I trying to say now in a nutshell? I will consider this one as Y, and I consider this one as what? X. Then permit me now to inside those elements inside. Now let's start with the son. What are the elements there? The first one is what? Y. I will write one. I will write one here. The second one is what? 2. Am I going to write it here? No. I will still write my 2 inside. Are you there now? So which means we are done with the son. So the next thing we are going to observe is the father. Are you there? Now the father, the first element there is what? 1. So it is wrong for me to write 1 again because 1 is already inside the father. Are you with me? So you ignore 1 because it's already there. I'll now move to the second element. The second element is what? 2. 2 is already inside the word father. You ignore what? 2. Are you there? Then let's consider the third element. What is it? 3. So 3 is not in the son. So which means 3 will appear here. Am I communicating? Then finally is what? 4. 4 will also appear here. Anywhere here around. So this is the Venn diagram of what we have just explained based on what? Subset. All right. So having defined the third one, let us quickly move to the fourth one. Are you there? So that is exactly what you mean by the word subset, by the word subset. Okay, number what? 4. Number 4 is what we call power set. What we call what? Power set. What did I say? Power what? Set. Now, let me ask you something here. Can I permit me to go back and explain a little on the subset again before we now enter on what we call the power word set? It is the subset that produces what we call the power set. How? Okay, let's take for instance, this father here always give the son 1,000 naira every day. Let's assume that now. Every blessed day, he will just give the son 1,000 naira and keep on doing it for over and over and over and over again. Do you know that there will be a time whereby the father will get tired of giving the son what? 1,000. Am I communicating now? And where the son will get tired of asking the father or demanding 1,000 from the word father. So what exactly will the father do in order the son should stop disturbing him? Giving him 1,000. So if peradventure the father is a big man or working or he has money, the best thing is to establish the son. Are you there? And once you have established the son, so which means there is no need again the son will disturb what? The father. So at that process now, this son now is no longer a subset to the word father. Are you with me? It's no longer a subset to the word father, which means it is now on its word's own. Am I communicating? So now that will now lead us to what we call power word set. Oh yeah, watch. Power set is simply the number of subsets which a particular set word has. I repeat, I say power set is the number of word subset which a particular set word has. Now I said power set is the number, is the word number of what subset which a particular set has, which a particular word particular set has. Are you there? Now, the question is, what is exactly the symbol to represent a power set? And what is exactly the formula that is given to power word set? Now, anytime you encounter this, watch. What does it imply? The cardinality of the power word set. And the formula is always given as 2 raised to power n. 2 raised to power what? N. So which means anytime you hear the word cardinality of the power set, the formula is reflected by 2 raised to power what? N. Where n signifies what? I've discussed it. N signifies what? Cardinality. Signifies what? Cardinality. Which I said before, cardinal set is the number of items contained in what? Set A. Am I set A or set? Are you there? Now, the question is, can we now look at few examples? Watch. Now watch. If our set A is given as this, x is this, is a prime number, is a prime number, is a prime number less than 11. Less than what? 11. Now the question is this. Watch everybody. Question number one. How many subsets? How many subsets has set what? A. How many subsets has what? Set what? A. Then number B. List all the subsets. List all the subsets of what? Set A. Are you there? Now, can you observe this question? I repeat. If set A, X is such that, now, this symbol that you're seeing here signifies what? Such that. Anytime you see this symbol in a set, we call it what? Such that. X is a prime number less than what? 11. Now, the question is, how many subset has set what? A. Now, the second one is list all the what? Subset of set what? A. Oh, yeah, watch. Okay, oh my goodness. Can I draw your attention again from the question? Now, the interpretation is that X is such that X is a prime number less than 11. Now, the question is, what do we mean by the word prime number? Because if you don't know what a prime number is, we cannot answer this set. A prime number is a number that has two factors. A prime number, I say it, prime number is a number that has what? That has two factors. Two what? Factors. Itself and what? One. Are you there? I repeat, a prime number is a number that has two factors, itself and what? One. So what am I trying to say? When a number exceeds two factors, it is not a prime number. And also when a number is just one factor, it is not a prime number. So which means a prime number constitutes just two factors, and that two factors must be itself and what? One. So before we tackle this question, can we list some prime numbers? Let's say that is up to 30. Are you there? Before we start. Now the prime numbers up to 30, we start with what? 2. Now, do you know why I did not start with 1? Because 1 just have one factor only, so it's not a prime number. But these two you are seeing now has only two factors. What are they? Itself, which is 2, and 1 is the only number that can divide what? 2 without what? A remainder. I will now move. Is 3 a prime number? Yes. Is 4 a prime number? No. 4 has more than 2 factors. 1 can divide, 2 can divide, and itself. Can you see it is 3 now? So 4 is not a prime number. Then 5 is a prime number. 6 is not. 7 is a prime number. 8 is not. 9 is not. 10 is not. Then 11 is a prime number. Then we'll move over to 12 is not. Then 13 is a prime number. Then 14 is not. 15 is not. 16 is not. Then 17 is also a prime number because it only has two factors, itself and what? 1. Then 18, no. 19, I think, is a prime number. Are you there? Then 20 is not. 21 is not. 22 is not. Oh my goodness. 23 is a prime number. Then 24 is not. 25 is not. 26 is not. 27 is not. 28 is not. Then lastly is what? 29. So these are prime numbers from 1 to what? 30. Then permit me now to go back to the question. The question says X is such that X is a prime number less than what? 11. Hope you can do it now. Oh yeah, watch. I will now list first of all the elements of the prime numbers that are less than what? 11. What are they? Say 2, 3, 5, and stop at what? 7. Are you there? Do you know why we are stopping at 7 is because they say less than what? 11. I have listed it. Now, haven't listed the member, so let's begin to solve the questions one after the other. Number A says, how many subset has set A? Now watch. Anytime you hear the word how many subset, what comes to your mind is power set. Is what? Power set. Are you there? How many subset is how many subsets simply means power word set. I defined power set before that it is the number of subset. Let me stop there. Number of what? Subset. Can you see? Number of subset is equal to what? Power set. So watch. We can now deduce by saying the cardinality of power set is always 2 raised to power NA, or can call it 2 raised to power what? N. Where NA is what? The cardinality of set what? A. Yeah, let's move to set A. How many items can we count? Oh yeah, 1, 2, 3, 4. So which means what is the cardinality is what? 4. I will now go to the formula. Anywhere I see NA, remove it and put what? 4. So that my cardinality of P is now 2 raised to the power of what? 4. Are you there? Then what is the next thing? This thing in this is simplify. Multiply to how many places? 4. It will now give me 2 times 2 times 2 times another word 2. Oh yeah, watch. 2 times 2 is what? 4. And 4 times 2 is what? 8. And 8 times 2 is what? 16. Oh my goodness. Now, what they will ask you now, how many subset has this? The answer is 16 words subset. We are done with question number what? A. All right. Now, can we move to the second question? Can we move to second question? So the second question says we should list all the subsets of set what? A. Now, what do you do? Number B, we want to list the subset. List the word subset. Now, all you need to do is very simple. List the subsets. All you need to do is very, very simple. Go back to the element provided here. You know, the elements are how many? The cardinality is how many? 1, 2, 3, 4. Begin to subset those items until it gets to how many? 16. It gets to how many? 16. Remember that I said that this thing that I'm teaching will help all of you based on the professional level, based on any exam that you may come across, based on the objective level, and based on the theory word level. Now, let's go back. So, how we should list them? What do you do? First of all, you should subset the sets, the items, one after the other, 1, 1. So, what do we do? The first element there, I hope, is 2, right? We have subset word 2. I will now write 2 separate. Then the next element that follows it is 3. I will subset 3 and write it separate. The next element that follows it is word 5. I will subset it separately. And the one that follows 5 is word 7. I will subset it separately. Can you see? I am done with 1, 1. I am done with what? 1, 1. But mind you that we are looking for how many subsets? 16. We just succeeded by knowing 4. So which means we are still looking for how many? 12. And I'm done with 1, 1. Then the next step is to pair it. Is to do what? Pair it. Pairing it means let it be 2, 2. I remember what I told you from the beginning, that anytime you are listing element, repetition is not what? Allowed. Oh yeah, let's go. Now, if you observe this, now look at it here. This is 2 and what? 3. Use 2 to roll it first. And I'm going to subset what? 2, 3. Are you there? Then I'll still subset 2, what? 5. Remember, we are pairing it now. 2, what? 5. And I'm going to subset 2 and what? 7. I will have 2, what? 7. Are you there? Can you see I am done by using 2 to roll it? Are you there? So the next is to move on to 3. Move on to what? 3. Use 3 to still roll it and pair it. So which means the first pairing for 3 is 3 and what? 5. Hope you are getting what I'm talking about. 3 and what? 5. Now, the next one is what? Watch. 3 and what? 7. 3 and what? 7. Now, if the next one, 3 and 5, 3 and 7, I'm done with 3. I will use 5 to roll it again so that I will have with me 5 and what? 7. Oh my goodness. I'm done with what? Pairing. It's improper to go back and say 3 and 2. 5 and 3 because it's already there. So I'm done with the pairing. Then the next thing is 3, 3. Everyone say 3, 3. 3, 3 is what we want to subset now. Then watch. From the video again, from the question I said over, this is 2, 3, 5. I will use 2 to roll it again. I'll have 2, 3, and 5. Oh yeah, watch. I'll pair it to have 2, comma, 3, comma, and what? 5. Are you there? I will still have, can you see 2, comma, 3, and 7. And what? 7. It's still 3, 3. I have 2, comma, 3, and what? 7. Finally, on 2 is what? 2, comma, what? 5, and what? 7. Can you see none of them is repeated? 2, comma, what? 5, and what? 7. Are you there? Then, comma. Now watch again. I'm done with 2. Next is to roll it with 3. So it will give me 3, comma, 5, comma, what? 7. I have with me 3, comma, 5, comma, what? 7. Oh, gentlemen and ladies, or ladies and gentlemen, I am done with the 3, 3. Now, but before I conclude, can we count the number of subsets that we have listed now? Yeah, let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and what? 14. So how many is left now? 2. Now, after the 3, 3, you now bring everything together the way it is. And what is it? Talk to me. We have 2, 3, 5, and what? 7, making it 15, right? And lastly is what we call an empty set. So I want you to know that one of the major characteristics of a subset is that it must contain an empty set. It must contain what? An empty set. Can you see if I count it all now? We have 16. Now, mind you, if we cannot identify an empty set with this symbol, you can still write it all 0 slash. It's still called what? An empty set. Now, this is exactly what we mean by listening the word subset. Have I made myself clear? Wow.